script real quick. Okay, so just started streaming, and we went through the story before I remembered to stream, and then we just discussed the basic commands inside of Git, and now we're doing a demo. Cool. All right, so where am I right now? Where am I inside in my terminal? What part of my computer am I in? What was that? Yeah, so this right here is going to give me an indication of where I'm at in my computer. Yes, the root. Cool. So if I was to go ls, maybe I want to look and see what files are here. There's a bunch of junk in here that's not relevant, but I do have this projects folder, and so I want to navigate to the projects folder. So I go cd, and I'll start spelling it out, and I can press tab, and it'll finish out the word for me. Press enter. So now I'm in the projects folder, and I can tell because it tells me right here. And if I, let's say for whatever reason my command line wasn't showing me what folder I was in, does anyone know the command that I could run to print out the directory I'm in? ls. So ls is going to show me the files, but to print out the path that I'm currently in. pwd, print working directory. Right, and so that shows me I'm at c/users/m, which is my username, and then projects. Right? All right, so now what we'll do is we'll create a folder. So we'll go mkdir. And we will just call this lc example 1. Okay, now let's say I want to do things inside this folder that I just created. This little detail trips me up all the time, and probably will trip a couple of you up when you're working on this. I just created that folder. In my mind, I'm inside that folder. However, I'm not inside that folder. I'm still inside the projects folder. So when I create a folder, I still need to navigate to it. So we'll do cd lc. I had another one. Cool. Now I'm inside the folder I just created. So from here, I can create a file, and the way I prefer to do it is with the code command. So I can either do it one of two ways. I can say code, and I can open up this directory I'm in inside of VS Code. So now I'm inside of this directory, and I can, create a file in here if I wanted to, or I'm gonna delete this. Or I can say code, and then I can come up with a file name, and I could say example.js for JavaScript. And then that just created the file for me. Sorry that the text is kind of small. I don't know if I have a fill work for me to increase it. There we go. Cool. So I was able to create a new file. And then now, to prove that I just created the file, I can run the ls command. So here we see example.js is now in our folder. And then if you have Node set up on your machine, you could do something like this. And this is a language-specific command. You could say node example.js. And that will run the file, which we set up to print out hello world. So I'm going to go ahead and back out of the folder, and then we're going to navigate back in it, just to sort of visually track with this here. So I'm going to go all the way back to my root directory, and I can do that with the shortcut, the tilde shortcut. Do that. I'm back at my root directory. So now let's go cd. We'll go projects. Oh, more than one. Projects, and then I can go even further than that. I can say lc example1 So I can navigate multiple folders at a time, or you can do it one at a time. We'll do multiple at a time here to prove the point. We made it back to our folder. Go back up again, back out. Two projects, cd, lc, example one. Cool. All right, so that was just me navigating around, running a couple commands. We're going to, probably the next thing we'll talk about is Git. So while we're thinking about just navigating the terminal, any thoughts, questions about this topic? Yes?
Hard is it to install that code?
The code command, it depends on what type of machine you have. So for a Mac, it's essentially it's Googleable, should be. I don't remember if when I installed VS Code on Windows, if as I was installing it, it gave me an option to include the code command. I think it did. On Mac, it's like a manual step that you'll need to Google. Yeah, it's a good question. So, but yeah, it is different for both. Other questions? All right, cool. We'll be hanging out around the terminal for a while longer. Let's go ahead and move forward. Git. Right, so there's this idea of version control. If anyone has a graphic designer background or any kind of background where you're dealing with like multiple project files, you've probably encountered this scenario, which is basically the image right here, where you like save the file name, and then you save another version of the file name, you save another version of the file name, you say this is the final file, and it's like, oh no, I had to change something. So this is the final file, and you end up with this big mess of a bunch of files, and it's all the same file that you're working with, but you just saved a bunch of versions of it because you're trying to clumsily implement version control on your own without using an extra tool, which is kind of what this example is. So this would be a solution, including with writing code, is that you just, as you need to, you just keep saving files and marking them which version it is. That's not a very good solution, especially when there are multiple people working on the same coding project. And so in walks Git. Git is a good solution for this problem. So with a version control system like Git, essentially you are able to save a file and then just committing it per se. And then you can commit it again and you can commit it again. And you're only working with one file on your computer. However, you do have the ability to go back in time and go back to a previous version of that file. So that's at one level of complexity. That's essentially what Git is it allowing you to continue to overwrite a file, but then to be able to go back and see where you had previously committed it. There's more to learn with Git, but that's a good place to start. Right. So what is this process of I called it saving. Saving is not the right word. We're going to use the word commit. What's this process of committing these changes so that we can go back to them at a later time if we need to? So in the command line, we'll do something like git status. And git status will tell us if we've made any uncommitted changes to our file. And if we've made changes and we haven't committed them yet, it's going to show up in red. We have not committed these files. And so we can add one or more files, multiple files really. We can add them. Adding them doesn't do anything just yet. And then we can commit them. And so it seems a little silly to have these three steps here. Why do we check the status and then we add them and then we commit them? Why do we have this middle add step? Well, a good example of why you might have this. Let's imagine if we are working on 10 files and we've edited 3 files, but 2 of them we're still working on and 1 of them is ready to go. What we can do with add is we can say this one file that's ready to go, I'm going to commit that one file. The rest of them I'm going to ignore. And so that's essentially the purpose of the add step of committing a file, is selecting which files you actually want to commit. And so a lot of times developers, what they'll do is they'll just always say like add all. They'll use the I think it's period to add all. And they never really think about selecting certain files. It's kind of a reckless practice. It's easy to do, but that's sort of the intention behind adding. So here's just a visual example. If we run git status, we have this one file down here called project.js, and we can tell we have unsaved changes to this file, essentially, or uncommitted changes. For add, we can say git add and the name of the file that we want to add, or we could do the name of the folder, etc. And then if we run git status again, we'll notice that the file has changed from red to green. So it hasn't been committed yet. It's just been staged, is the word for it. It's just been staged to be committed. Oops. And then finally, we can commit the file. And we'll look at the structure of what that commit command looks like on the next slide. But essentially, we're going to commit it and add a message to the commit. So here is an up close of what the commit message is going to look like. So we have git commit, of course, and then we have a flag. This is a very useful flag. This is how we're going to add a message onto our commit. And so we'll do git commit -m for message, and then in quotes we'll put whatever we want to say, really. Cool, I don't want to go to that next slide just yet. So one last note about when we commit a file. So we have this process of saying git status, tell me what's committed, what's not. We add the files, we commit the files, and then if we run git status again, we're not going to see our file show up. It's not going to show up because there's no unsaved or uncommitted changes to it. And we'll demo that in a little bit here. Before we demoed it, there's just something, this is, maybe none of you will run into this, but it's worth pointing out. When we want to work with Git in a folder on our machines, we're going to initialize Git init in whatever folder we're working from. If we're not careful and we accidentally add git init to our root directory, it's possible to cause some kind of awful problems. Long story short, I had a previous teacher of mine who had like 6 months worth of coding projects, and he accidentally git committed or git initialized his desktop. And so he was trying to undo it, and when he undid it, he basically like reverted everything, and it deleted all of his files on his desktop, which is a bunch of projects and stuff. And so he lost everything. And so he made sure to let me know not to do that. And so now I'm making sure to let y'all know not to do that. So just be careful where we're running git init. It is the concept of Git is contained to a project, right? And so we don't want to turn our entire computer into a version control project. Cool. So this evening, we're really focusing on the idea of using using Git on our local machines, meaning that we can use it without being connected to the internet. Everything's just happening on our laptops, right? Git gets really powerful when we are leveraging a remote repository. And so instead of the repository just living on our local machine, it's going to live on a website like github.com. And so what that means, and we'll learn more about this in the future, but what that means is you and another developer could be working in two different places on a project with a copy of the remote repository on your machines, and then you guys can pass code back and forth. It's a really nice system. It just takes a minute to get familiar with how Git is intended to work. So for now, we're not worried about the whole remote side of Git. We're just thinking about running it on our local computer, which is the same in both scenarios. All right, so let's go ahead and demo this. So we already have our example folder that we created a minute ago. So let's go ahead and turn this into a Git repository. So in order to do this, first let's check if it is a Git repository or not. So how we can do that is just say git status, and it just tells us it's not a Git repository. We can't run that command here. So we can say git init. It says initialize git repository, and it says that the path. And you'll notice in my terminal, it now has this thing right here. It says main. Main is the branch I'm in. More on that later. So now we're actually working with a git repository. And so now if I say git status, we can see that the example file we created earlier, it's never been committed. So it's letting us know, hey, we should not that we should commit it, but that there's a file waiting to be committed. Okay, so what would be the next step if I wanted to commit the changes to this file? Add. Okay. Git add, and then what comes next? So I wrote git add, and there's a bit more that I have to type out. Heard example .js. Cool. Now, does that commit it? No, it doesn't commit it yet. We can see where we're at in the process by saying git status. It's in green, which means it's been added. And so now we can say git commit. What's the next thing I need on my commit message? -m. And then I can say, since I'm saving the file for the first time, I'll basically say added example.js. Right, and so now that's been committed, so if I say git status, it's nothing. It looks empty, but it just means that there's nothing waiting to be changed. If I do ls, I still have the file. It's just what git status is trying to communicate. Cool. So let me show maybe another example. I'm going to create another file. We will call this something very creative. Yes, of course.
So you just listed the files there for example.js.
Mm-hmm.
So since the repository lives outside of your local machine, right?
In this example, it doesn't. So that what you might be thinking of in terms of a repository living outside of a machine would be a remote repository.
Oh, okay.
Right.
So I guess I'm trying to understand
where the Git files are.
Well, what does it? Can you like? How does that affect the file itself? Does the repository have any effect on the file itself?
Does the repository have any effect on the file itself? Yeah, that's a good question. Let me see if I can. I'll pause where I was going with creating the other file. Let's see if I can. No, you're good. It's a good question. So remember the command to say is to see hidden folders or hidden files. It would be ls dash something dash a. Cool. Oops, I did something wrong. Ls dash a. And so we can see that there is a hidden Git folder in here. And so essentially what Git's doing behind the scene is it is not changing the files. However, it is storing in memory all of the commits. And so hypothetically, in a future state, let's say we committed the file several times and we wanted to go back to an earlier commit, we could load that earlier commit, and then at that point, Git does change the file because it replaces it with the earlier one. And so working with a file with Git enabled, you're not going to notice a difference until you basically tell it, hey, I need you to restore a previous version or in a future state, pull down these changes from the remote repository, etc. Right? Does that help? Do you have more questions on that?
I was just curious because I was asking, what would it have been the end of the world if your professor who accidentally created that giant repository, if he just left it?
If he just left it.
Did he need to undo it? Or maybe he didn't know that undoing it would delete everything.
Right.
If he just left it, then how would that have changed? But from what you just explained, it sounds like if he did create this repository for all of his files, it just would have been a bunch of wasted memory.
Yeah, hypothetically. Also, if you wanted to create a Git repository somewhere on his desktop, maybe there would have been weird issues because it was already inside of a Git one. I don't know. I don't really know for sure. exactly what type of chaos it caused. I just know that when he tried to fix it, he accidentally deleted everything. Yeah. But cool. So yeah, pausing here. Other questions for where we're at? Yes.
What if you don't? What if you get a type of message? How would you fix that?
Oh yes, I definitely I've got that in my slides because that's a common thing that comes up. The question was, what happens if we create a commit message or if we commit a file without a message? How do we fix that? We'll show an example of that in just a moment. So I'm going to make another file, example2.js. All right, so now I've made changes to this file. I still have to save the file, right? I made changes and then I press Control S to save it, or you can save it however you want to. I still need to save the file for there to be changes for Git to recognize. So now if I jump back over to my terminal, just running ls so we can see we have two files. If I could do git status, example2 hasn't been added to the repository yet. Okay. Now I'm going to show something. So if I go back to example 1, let's say I make a change here. Okay. Oops. Cool. So I've made a change. Now if I go to my terminal, say git status, I don't see the changes I made to file 1. And the reason why I don't see them is because we notice this white dot here is VS Code's way of telling me that I didn't save my changes. So I'll save it, I'll say Control S, it saves it. And now if I do git status, wait. All right, yeah, I have the two files. This one was modified and this one was never added to the repository. And so I could include both files in a commit by saying git add all. I don't like doing that particularly because what I've seen a lot when developers always just do git add all because it's easier, is oftentimes they'll accidentally add files they didn't intend to. So I like being a little bit more careful with git. And so we'll say git add example2. So now if we say git status, we've got one file that we're preparing to commit our changes to and another one that we're ignoring for now. So now I can say git commit. And to the question earlier about what happens if I don't have a message on here, let's find out. Press enter. Oh no, what is this? This is something called Vim. I have 2 slides about it, but this is probably a better example. So Vim is basically, it's like VS Code for the command line. It's a file editor inside the command line. And so the way you interact with it is a little funky if you've never done it before. So here I can press I to insert a message. So I'll say adding example2.js. So that yellow text there is my commit message. Then I can press, if you notice the bottom left-hand corner says insert, I can press escape. I'm still inside of Vim. And then I can press colon WQ, which is write and quit. So we'll write the file and then quit Vim. I press enter and we're done. We survived Vim. So you don't have to learn Vim. But if you do accidentally forget to add a commit message to your commit, you will have to learn Vim, like at least enough to get out of it. So it's a little bit easier just adding a message to your commit. Cool. Awesome. Other questions while we're here? Yes.
Why wouldn't you want to add like all files? Like if you didn't need or if you don't want to add files, like anyway, what's the worst case? Like, is it a memory issue? Is it like
That's a good question. Right. So the question was, why wouldn't you just want to add all of your files? Is it like a memory issue or something else? And I'll provide two scenarios. Scenario one, you are working on Facebook, the app, and on your local machine, you have the password to the database. You really don't want that being out there in the public. On GitHub, where someone could find your database password and do whatever they want with it. And so you type in git add all, the dot, and then you accidentally commit your database password to GitHub. And someone is moseying through GitHub, they find your database password, or there's actually entities out there that will scan GitHub for database passwords. They'll have like their own automated little tool doing that. And then once they have your database password, they will either, you can't trust them with this, so who knows what they'll do. So that's scenario one, which would be, okay, there's a security risk in potentially accidentally saving credentials, particularly outside of your computer if you're working with a remote repository. Scenario two is, we talked about NPM previously. We've worked with it quite a bit in the sense of like we're able to download other repositories from other places on the internet. And so when we install these little tools in our program, it's essentially considered like derived code. It's not our own code. And so if we were to commit all of those files, we end up just having a ton of clutter that we're tracking with Git. And you probably haven't seen it so much just yet, but once we really get into working with VS Code and we're installing these other things, you can have like a folder filled with other folders. It's a bunch of the node modules, the NPM stuff, and you don't want to commit that. And so those are probably the two best examples. Is you don't want to commit things that are for security reasons that might be a secret, and then you also don't want to commit things that are just junk that you don't care about, that are necessary for running your app but aren't necessary for your Git repository. Yeah, great question. Cool. Yes.
I'm curious about the difference between using the terminal in Git Bash and then the terminal in the Visual Studio Code.
Right. So that actually depends on if you're on Windows or a Mac. So not to get too far down the weeds here, but essentially Mac and Linux are both essentially built off of Linux. Git Bash is a Linux style terminal. And so if you're using Git Bash, which is a Linux style terminal, or you're using the terminal on a MacBook, which is also a Linux style terminal, they behave basically the same way, essentially speaking. If you're on a Windows machine and you use the Windows terminal, it may not be set to be Bash. Let me see if I can. Right, so this is a PowerShell terminal, which is similar in many ways, but definitely different. And so I can still run ls and some other things, like some of the basic commands. But essentially, for development purposes, we're probably not going to be using PowerShell intentionally. Right, so yeah, that would be the difference between Git Bash and the VS Code terminal. You can set up your VS Code terminal to be Git Bash, and that would be probably recommended. Yeah, great question. Cool. Other questions? Yes. Is there a way to change it to Git Bash in Visual Studio Code? Let me actually see if I can figure it out on the fly. I think the workbook mentions it. There's probably a. Oops, just creating more PowerShells. Don't want to do that. I'm not sure on the fly. I'd probably just Google it and figure that step out. And it might be mentioned in the workbook. I'm not sure if it gives the steps or not. It does? Cool. Awesome. So somewhere in the workbook. Also, the workbook is searchable, which is really great. So if there's something like that we're mentioning, like setting your terminal to Bash, you might be able to search it, which is pretty cool. Awesome. Other questions? All right, cool. Okay, so there's a concept of branches. So what we've been discussing so far with Git is essentially like a linear process. You have, if you think about it in terms of like a timeline, like a history. We create a commit on this point in history, and then later on we create another commit on this point in history. And so we just sort of have like this two-dimensional thing. I don't know if describing it in this way is helpful or not, but yeah, essentially it's a file, and you can go back in time and see the changes you made. You can jump back forward in times, etc. So with branches, it is essentially adding another dimension onto this. So with a branch, if you're just on one branch, everything works linearly. However, you can create another branch and work almost like parallel on the same project. And the main purpose of having multiple branches really comes out when you're working with multiple developers. And so hypothetically, imagine if you are working on a team of 2 developers and you're both working on the same project and you're both working on the same file, but you're working on 2 different things. Maybe they're working on something that collects input from the user, and maybe you are working on something that sends information to the database, right? And so you both create your own branches, your own versions of the project, essentially. Create your commits along the way, and then eventually the goal is that you'll merge those 2 branches back together, or back into like one main branch. And so, yeah, hopefully that is like sort of a helpful explanation. One analogy I think might be helpful, and this is going back to individuals who have some experience with like photo editors. You could sort of think of a branch as like a layer in like a photo editor. So maybe I'm working on this layer, and I can do different things to this layer. I can edit the file, etc. And maybe my colleague is working on this layer. They're really good at drawing foxes, and so they drew this fox. And so we can, in the end, we can merge the 2 layers together on the project as it goes along. And maybe colleague number 3 is working on this layer. And so we can merge all of our work together, and then we have something like this. But we could also say, hey, actually, I don't like this work you did. It kind of breaks the project. And so we can say, we're not going to add this to the project. But that's more team dynamics, nothing that is super relevant right now. So that's one way to think about different branches, is they're almost like different layers in like a photo editor, both working on your own layer, and then eventually they'll come together to create the image. So for, I guess, more of a technical example, let's say we have a basic app that takes the user's name and age, and it console logs, hi, so-and-so, you're how many years old or whatever. You create another branch called dog years. And essentially you're modifying the code to print out the user's age in dog years. And so you add this line right here, let age in dog years equal age times 7. You modify the console log statement, right? And so we have our main branch, which has the original code. And then we have our dog years branch, which has the changes that we're working on. Eventually, we're going to merge the dog years branch back into main. And essentially main is now going to inherit all of those changes. So now main is going to look like this. It's going to have all the dog year changes. Right. Cool. So pause on branches. Questions on branches? Yes.
Just a question, if you were to merge files, is it an easy option, or do you have to check it line by line to make sure it's
Oh yeah, very good question. So this question was essentially, when we are going through the process of merging one branch into the other, do we have to check each line of code to make sure that we're not accidentally breaking the file, essentially, right? So Git is really good about doing that for us. And so Git will use all of its intelligence in heavy quotation marks to merge the changes without breaking anything. However, there is a scenario in which Git says, hey, I don't know what to do with this. These two things are conflicting. And so it will generate a conflict. And so you, as the developer, will resolve the conflicts. You'll get a block of code from the first branch and a block of code from the other branch, and you have to just decide, which one of these blocks of code am I going to keep, or am I going to merge them manually and just type out the code manually? And so essentially, merging, it will do it automatically for us. Very nice. But there may be times when it doesn't figure it out automatically, and we have to manually correct it. And so resolving merge conflicts, it's something you kind of want to practice. And I think we'll have an opportunity to in the future. I think that's going to come up in the studio. If not, it will definitely come up as you're practicing. Yep. Cool. Great question. Other questions on branches? Yes.
So I suppose when you merge them, what is the level of the intelligence? So for instance, if someone uses, instead of Asian dog ears, they just used dog ears, variable names, is that really nitpicky? I'm assuming you would talk to that with whoever you're working with, but I'm just not.
Right. So I guess your question is more along the lines of what's the scenario in which we likely have a merge conflict?
Okay. Yes.
Right. So the scenario that merge conflicts are most likely to arise is, let's say hypothetically, we have our main branch. That's where all the code's going to go eventually. And we have developer A who is working on a file and developer B who's working on a file. Okay. Now let's say developer B merges their changes back into main. And then let's say you're merging your changes back into main after they do. What could cause a conflict is if you both edited the same section of code, is it will say, hey, there are changes in here that are newer than your changes. So whoever merged their changes first, those look like they're newer changes than the changes that you're trying to merge in. And so then it will generate a conflict. That's usually the scenario. If that didn't quite make sense, that's okay. It's a little bit easier to be familiar with the flow of things after you're practicing it and stuff. But yeah, usually that would be the scenario. Yeah, cool. Other questions? Yes.
What's a good way to visualize branches or orient yourself in branches? You're a new developer, you
Mm-hmm.
how do you know where you are? How do you know what other branches are?
Okay. We can look at a couple commands for branches. I will say there is practice built into some studios in the future, if I remember correctly. In my opinion, the best way to practice branches is where yourself and another developer are on remote repositories or connected to the same remote repository, and you're having to work together. And so there is a studio that has you practice that. And then also I know during Liftoff, which comes after this program, working on a team with other developers developing an app. That's sort of the structure of Liftoff. There's going to be a lot of collaboration in that way. Yeah, let's look at some branch commands. Right, so currently we are on the main branch. If I want to see all the branches, I do git branch -a, and I only have one branch. So not much there. To create a branch locally, in my normal workflow at work, I almost never create a branch locally. I'm usually creating a remote repository, but let me see if I can remember how to do this. Git commit branch artwork. Is it this? No, it's not. I will actually field this to y'all. Does anyone know offhand how to create a branch locally before I Google it? Yes. That sounds right. Git branch and then the branch name. Work. Git branch dash. Yeah, it worked. Okay, that was, yeah, cool. So now, all right, so the terminal is helpful right now in that it is telling us which branch we're on. We can see that we are on the main branch. Now, if I wanted to switch branches, I could say git checkout aardvark. And so now I switched over to the aardvark branch. Once again, my terminal is very helpful. It's telling me, hey, you're on the aardvark branch because it's right here. You see it. And so I can do all of my work here. And then when it comes time to merge my changes back into main, what I can do, if I'm doing this all locally, is, hold on, git checkout main, starting from the main branch, git merge aardvark. Now, if there were changes, it would merge them back into the main branch. There were no changes, and so it's like, hey, we're already up to date. So that's a workflow for creating a branch, merging it back in, etc. And then you'd probably want to delete the branch afterwards if you were done with it. Yeah, so that's a workflow. Cool. More questions on that process that we just did, or other questions in general on Git? Fun stuff. Cool. All right, we already talked about Vim. Let me see if there's anything useful. This might just be a reference for y'all. This explains how to get out of this whole commit message Vim thing. Essentially, escape will toggle whether you're in command mode or edit mode. Edit mode allows you to write the message. Command mode lets you write the WQ thing that exits Vim. Eyes for insert, yeah. I think this will be more helpful as a reference than to talk about too much here. Before we progress and start talking about HTML, which I think is kind of fun, questions on Vim while we're here in the slide deck. Yes?
Do you think that's common in the actual field to see it on a regular basis?
To see Vim? Yeah, there are some developers out there that like to code in Vim, and that's just what they do. They code in Vim. So I haven't met many of those people. Yeah, so like, I mean, anywhere you're using Git, you're probably going to see Vim. Vim could be useful if you needed to like make a tiny change to a file and didn't want to go through the process of getting to the file or whatever. Or if you needed to create a simple text file, Vim could be useful for that. If you get into the whole DevOps world, which is essentially the world of deploying applications on servers and stuff, Vim might be helpful in that environment if you don't have access to a command to like a desktop application like VS Code. Maybe in that world where you're deep into the terminal, you don't have a desktop, you might need to use Vim, not hypothetically. But personally, if we have access to things like VS Code, much prefer it. Just because VS Code it's giving you tools, and we'll see more in VS Code. You can install extensions into it and stuff, which makes life easier. It really is a worthwhile tool. Yeah. Good question. Cool. HTML. So kind of as I predicted, I guess Monday or Thursday, if I can get my week right. Wow. My brain broke. So I believe it's Monday. We don't have a lot of time to talk about HTML today. Fortunately, we kind of talked about it a bit last class, but let's review what we have time for. So all web pages are made with HTML. Essentially, that's the structure of the web page that we're seeing. We're seeing HTML rendered. An HTML file will have an extension of .html. And so a home page for a website is always index.html. And the web browser hides that from us typically. So if we go to www.mywebsite.com, we're actually visiting that index text file, the HTML file. That's what we're visiting. The browser is what is displaying everything nicely for us. The general structure of HTML syntax is that we have elements, and then an element has like a pair of tags, an opening tag and a closing tag. So you can see right here. Oops, skip forward. And then in general, the structure of an HTML file is that the entire HTML is going to be inside the HTML element. So opening HTML tag, closing HTML tag. Inside of there, we'll have a head and a body. The body has the visual content. Then the head has the non-visual stuff like importing files and things like that. So here's an example. We see we have everything's inside of the HTML element. We have the opening HTML tag and the closing HTML tag down here. We have the head is this first element, next layer down, next level down. And it's got the title of the page, and this is also where we'd import stuff and have a bunch of metadata. Underneath that, we have the body element. And this is where all of the visual stuff comes in. So I'm going to show CodePen. Let me see if I can get the right zoom on this. CodePen is not an official part of LaunchCode curriculum and stuff. This is just a tool I like because it's a very fast and easy way to demonstrate something with HTML. And so remember that HTML is essentially just a text file. However, what this website is doing is we have our HTML file, and then it's automatically importing our CSS and our JavaScript. So we could type in our HTML, we could type in our CSS instead of having to manually configure things. So if you notice, we have our H1 tag. I can add another element, P, which is supposed to mean like paragraph. I can just put stuff in here. And then that will show up right here to the left-hand side. This is like my web page. So with the time we have, questions on HTML or anything you want to see demonstrated or something you want to try out with HTML, that would be a good time to explore stuff. Cool. Well, I will throw an example out there. What would we do if we wanted to create a link in our HTML, a clickable link that will send you somewhere? A tag. Okay, start writing one. Okay, so we have our link right here, but how do we tell the link where to send us? Something like this. Awesome. Yes, this href thing. And so in here we can put the link to where we want it to send us. Now, this is just a tangent. If you ever wanted it to open it in a new tab, target equals pound. This should open google.com or something went wrong. Probably something weird with it being in CodePen. But yeah, essentially that's how a link would be set up. And then you also have images, you have all kinds of things. And then, yeah, a lot of fun stuff to explore. I'm excited for when we transition more into HTML stuff because it's fun. All right, cool. So we're pretty much at time. We got like 2 minutes. So any last questions before we transition to Studio? No? All right, cool. All right, thanks everyone. I'll see y'all in a bit.